Hello, this is Dr. Hanaa Assil. This is Unit 2 of May 2023 in the Pearson Edexcel International A-Level. Let's take a look at the questions and discuss their answers. The first question was, enthalpy level diagram for reaction is shown, which is represented by this diagram. So we look at this diagram and we find, is this a diagram of exothermic or endothermic reaction? Of course, when the products have less energy than reactants, this is an exothermic reaction. So the question is, which of these options is exothermic? So in order to do A is delta H of atomization. This needs energy, so this is endothermic. This is ionization energy. This also needs to take in energy, so it's endothermic. What about this one? This one is basically the bond enthalpy of chlorine. So this is energy released when a chlorine molecule is formed. So this is the one that's exothermic. Of course, the last one is the delta H of dissolving or delta H of solution. Excess zinc powder is added to 50 grams of 0.5 mole per decimeter cubed copper sulfate solution in a polystyrene cup. The mixture is stirred, maximum temperature change determined. The enthalpy change for the reaction, they found that delta H is minus 185 kilojoule per mole, while the data book value is actually minus 217 kilojoule per mole. So what is the percentage error? How do we get percentage error? It is the difference over the actual value times 100. So if you calculate that, it comes out to be 14.7%. The next part of the question says, in the calculation, the specific heat capacity of the liquid is taken to be 4.18 rather than the true value of 3.85. The use of this larger number in the calculation does what? Remember that when we're calculating Q is mc delta T, we take C as 4.18, even though this is the value for water, but we also use it for solutions. So this is a larger value than the value that we're going to use. When we use larger values, that lowers the error, or it lowers the percent error in the answer. The enthalpy changes for two reactions are shown. What is the enthalpy change for the reaction between iron 3 oxide and carbon? So he gives this equation, Fe2O3 plus 3 carbon to give 2Fe plus 3CO, carbon monoxide. We want the delta H for that reaction. We need to use the information given. You will notice that the information that is given is actually the delta H of formation for each of these. So the first equation up there is the delta H of formation of Fe2O3. The second equation is the delta H of formation of CO. So I can use that in a Hess cycle where we have the elements in the lower box to give the reactants and to give the products. Notice that we are trying to form 1 mole of Fe2O3, so that is minus 824. Remember that elements do not have a delta H of formation. So the delta H of formation of carbon is 0, delta H of formation of iron is 0. And in the product, we have 3 moles of CO, so I need to multiply the number given by 3. Now, going around the circle, you will find that delta H minus 824 is equal to the other one. So you can calculate delta H. This comes out with a positive value, so it's plus 491. Which of these alkanes would be expected to have the highest boiling temperature? Now, how do we determine which one has highest boiling temperature? First of all, we count the number of carbons. the one that has more carbons has higher boiling point. Now, if they have the same number of carbons, then the one that has less branching, or it is a straight chain, that would have the highest boiling temperatures. So if you look at the choices that we have here, you'll find that D has larger number of carbon atoms, and that is the first basics for choosing the highest boiling temperature. The boiling temperature of hexane is 69 and that of cyclohexane is 81. The main reason that cyclohexane has a higher boiling temperature is that the molecules have what? Okay, what is hexane? This is hexane, a straight chain hydrocarbon. Cyclohexane is a cyclic compound. Now, first of all, we said that if something is a long chain, it should have higher boiling points than something that is branched. But let us look at the choices. We're saying, first of all, he's saying cyclohexane has higher boiling temperature. And the question is why? Is it because they have more electrons? No, actually, cyclohexane is C6H12. Now, the straight chain is C6H14. So actually, the straight chain hexane has more electrons than the cyclohexane. So A is wrong. Is it because the cyclohexane has strong permanent dipole-dipole forces? Well, actually, it doesn't have dipole-dipole forces because it doesn't have any electronegative element anyway. So is it because it has a larger surface area? That must be the reason. That means that the cyclohexane is in a form in which it has a larger surface area, and that is what would give it a higher temperature. Now, if he says it forms hydrogen bonding, no, cyclohexane does not form hydrogen bonds. To have hydrogen bonds, we must have hydrogen attached to an electronegative element, and of course, this is not the case. So, the next question says, the structures and boiling temperatures of butane and propanol are shown. The main reason that propanol has higher boiling temperature is that propanol molecules have what? Again, if we look at the difference between butane and propanol, butane has 4 carbons, but propanol has only 3, but the interactions between butane molecules would just be London dispersion forces, which are weak, but propanol has what? Propanol has dipole-dipole interactions due to the permanent dipole between the carbon and the oxygen. So this is why we would have higher boiling point for propanol, since the dipole-dipole interactions are stronger than the weaker van der Waals forces or London dispersion forces in butane. Hydrogen bonds are formed when methanol dissolves in water. Which structure best represents a hydrogen bond between methanol and water? First of all, you should realize that the hydrogen bond should be between an electronegative element and hydrogen and an electronegative element of the next molecule. So if we look at that, C and D are wrong. We don't have the carbon attached to hydrogen forming hydrogen bond. It is oxygen attached to hydrogen that would form a hydrogen bond. So the answer is A or B, but the difference is in A, the angle around the hydrogen has to be 180 degrees in order to form a hydrogen bond. And of course, we must have an electronegative element like oxygen, so this is slightly negative, attached to a hydrogen that would be slightly positive, so that would make a hydrogen bond with the next molecule. In which pair of compounds is the stated element in the same oxidation state. So we determine the oxidation state for each one. How do we determine oxidation states? Remember, if I have Cl2O7, each oxygen has oxidation number of -2. That means I have a total of -14 for the oxygen. So the two chlorines must be a total of +14. That means each chlorine is +7. Now, in the other molecule, we have calcium is +2, and I have 6 oxygens. Each of them is -2, so that's -12. That means I need a total of chlorine for +10. So each chlorine, I have 2 chlorines, so each chlorine is +5, and so on. If you calculate for this, this is where you have the chromium in the same oxidation states. If we calculate for manganese here, the manganese has different oxidation states, and here the potassium has different oxidation states. So the answer is the one for chromium. What is the formula of barium ferrate 6? First of all, if we don't know what is ferrate, obviously from the choices it's Fe and oxygen. But the question is it FeO3 or FeO4? And what is the oxidation state for each one? Barium is 2, so barium has to be +2. The iron, he tells me that the iron is +6. That means I have a total of +8, so the oxygens must be a total of -8. So I need 4 oxygens and 1 barium and 1 iron. That would make the total equal to 0. The oxidation number of the total molecule is 0, so this must be the correct formula. When lithium reacts with excess oxygen, only lithium oxide is formed. When sodium reacts with excess oxygen, it forms sodium oxide, sodium peroxide. Both of them are formed. What is the main reason why sodium peroxide is formed? Why does sodium form more types of oxides than lithium? Well, if we look at the periodic table, which one is supposed to be more reactive? The lithium is at the top of group 1, sodium is lower in group 1, and we said the one that is lower is more reactive. So sodium is more reactive than lithium, but that is not why it would form more oxygens around it. The difference between sodium oxide and sodium peroxide is that you have sodium and 1 oxygen around the sodium atom. Of course, the oxygen, we need 2 sodiums, but if we're looking at the sodium, so 1 sodium with 1 oxygen. Now the sodium peroxide, you have more oxygens around the sodiums, so this must be because the sodium ion has a larger ionic radius than the lithium ion. A piece of sodium weighing 1.15 grams reacts completely with distilled water, and the solution formed is made up to a volume of 250. What is the concentration? So in order to get the concentration in mole per decimeter cubed, I need to get number of moles. So number of moles of sodium is mass over molecular mass or atomic mass of sodium. So that comes out to be 0.05 mole. Now we are going to put this in what? This is the number of moles of sodium. We are asking about sodium hydroxide. So from the equation, the relationship is 2 moles of sodium gives 2 moles of sodium hydroxide. And that means the number of moles of sodium hydroxide is the same as sodium. Now we're going to put this in a volume of 250 centimeter cubed. Remember, we need to divide it by 1000 to change it to decimeter cubed. So the concentration is the number of moles over the volume. Magnesium nitrate decomposes on heating. A sample of magnesium nitrate decomposed completely. The total volume of gas was 1200 centimeter cubed. measured at room temperature and pressure. Of course, when he says room temperature and pressure, that means we can use the equation of number of moles is volume over 24, or over 24,000 if the volume is centimeter cubed. So, what is the mass of magnesium nitrate that was used? If we get a total volume of gas in the product, 1200 centimeter cubed, then I can get the total number of moles of gas. Number of moles is volume over 24, so the total number of moles of gases is 0.05. That means that is the total number of moles of the NO2 and O2. Now we look at the equation and we relate it. The equation says 2 moles of magnesium nitrate should give how many moles of gas? It should give 4 NO2 plus 1 O2, so it gives a total of 5 NO2, 5 moles of gas. So if 2 moles of magnesium nitrate gives 5 moles of gas, then the number of moles that we have, which is 0.05, will give how much? So it will give 0.05 times 2 over 5. So that is the number of moles of magnesium nitrate. Now to get the mass of course is number of moles times the molecular mass, which is already given in the equation, and that gives a mass of 2.97 grams. When solid sodium chloride is placed in a Bunsen flame, a persistent yellow color is observed. The yellow color is due to what? Remember when we talked about flame tests and we said putting different metal ions in the flame will give different colors. Now why is that? We should remember that we get a color in the flame test because the electron in the atom gains energy and jumps to a higher energy level. That is called an excited state. Now, this electron wants to go back to its original energy level. It gives out the amount of energy that it absorbed at the beginning. Now, this energy in the visible region would give a specific color. So the reason that we get colors is that electrons being excited to higher energy levels by absorbing a certain amount of energy, and then they emit this amount of energy again on returning to the ground state. In a series of experiments, the time taken to complete the reaction between iron 3 sulfate and sodium thiosulfate is measured. 1 drop of a solution of a substance is added to separate reaction mixtures. Which ion speeds up the reaction? So which of these substances basically is acting as a catalyst? A catalyst means it would make the reaction faster. If it makes the reaction faster, that means the reaction would take less time. So the question is, which of these gives a reaction with less time? That is copper. So it is copper 2 that is acting as a catalyst. Hydrogen peroxide decomposes in the presence of a catalyst. The volume of gas formed is measured at regular time intervals and the data plotted. What is the rate of formation of the gas at point X? Now, rate of formation, the rate is basically the volume per time. But if the graph is a straight line, then you can get this directly from the graph. You look at the volume at that point, the time at that point, and volume over time should give the rate for a straight line graph. When we have a curve like this, we want to get the rate, we have to draw a tangent at that point. So the tangent at that point, you find the y2 minus y1 over x2 minus x1. So the volume of gas is 25 minus 12.5, and the time taken is 9.5, so the rate. Okay, Structures of 3 bromoalkanes are shown. Which of these bromoalkanes may be classified as tertiary? Again, which one would be tertiary? The one that has the Br attached to a carbon that is attached to 3 other carbons. That's a tertiary. So which of these is a tertiary? You can see the Br here is attached to 3 other carbons. So this is the tertiary. P is a secondary and Q is a primary. We're looking at the carbons to which the Br is attached. When 1-chlorobutane is mixed with ethanol and aqueous silver nitrate, a reaction occurs. Which species is the nucleophile? Okay, when we react a halogenoalkane with aqueous silver nitrate in ethanol, what happens? The Br is replaced, or the Cl in this case, or Br is replaced by an OH, and that means what we're doing is we have water, hydroxide ions from the water is attacking the slightly positive carbon to release the halogen, bromine or chlorine. So this is the nucleophile in the reaction. Propane 1-ol may be converted into propene. Which reagent is used for this reaction? If I have an alcohol and we change it to an alkene, we use concentrated phosphoric acid. This would remove the H and OH and put a double bond. So what type of reaction is this? Again, if we're removing H and OH and forming a double bond, this is an elimination reaction. In section B, the question says, some reactions of a halogenoalkane are summarized in the diagram. All the reactions are of the same type and mechanism. Name the type and mechanism. So what is happening? We are replacing the Br either with an NH2 or an OH or a cyanide because he's reacting it with KCN. So that means this is a nucleophilic substitution reaction. Give the IUPAC name and the structure of compound M. What is happening in compound M? We're replacing the Br with a Cn. Now, how are we going to name this compound? Remember that we take the long chain that has the Cn. We count the total number of carbons in that. So I have 3 carbons with a nitrogen compound. So this is propane nitrile. And the methyl groups up and down are substituents, and they're both on carbon number 2 because we're going to count the Cn, the carbon number 1. So this is 2,2-dimethyl propane nitrile. State the reagent and conditions required for reaction 1. What was reaction 1? Trying to replace Br with NH2. What should I add? Ammonia in ethanol, and we said heat under pressure or heat in a sealed tube. So this would replace the Br with NH2. An incomplete mechanism for reaction 2 is shown. Complete the mechanism by adding curly arrows, relevant dipoles, and lone pairs. So, for the intermediate, what is happening? We said we have the C and the Br bond, or we have dipoles. The Br is slightly negative, the carbon is slightly positive. So the 2 electrons in the bond are given to the Br. That means I have the carbon lacking electrons. So now the carbon has a positive charge. This is called a carbocation, and the Br now has a negative charge. Then what happens? The lone pair of electrons on the oxygen attack the positively charged carbon. in order to attach the OH and form the alcohol. Are we familiar with this mechanism? Describe how intermediate J is formed in the first step, naming the process that occurs. What happens when we break a bond? Either both electrons go to one of the atoms. That forms positive and negative, and this is called heterolytic fission. Or we break the bond so that one electron goes to each atom. So this forms what we call free radicals, and this is called homolytic fission. Okay, what happened to form J? Well, in J, the pair of electrons, both of them are transferred to the slightly negative bromine. So this is a heterolytic bond fission. That is the process. State the shape of the intermediate J and justify your answer. What is J? This was J. This is a carbon with 3 bonds, no lone pair of electrons on the central carbon, and that means we need trigonal planar structure so that we have 3 bonding pairs of electrons, no lone pair on the central atom, so it has to be like this for minimum repulsion between the electrons. Minimum repulsion between the bonding pairs of electrons. The product of reaction 2 is this. This compound has 3 isomers that are alcohols. How can we, this is an alcohol with 4 carbons. How can we draw different isomers in which I have 4 carbons and an OH? So, and he's not specifying what type of structure. So it could be skeletal or it could be displayed. So one of them would have the OH on one end with all the 4 carbons in a straight chain. Another would have the OH in the middle somewhere. So that's the secondary alcohol. And the third will be when I have a branching so that I have the chain containing 3 carbons and a methyl group that is a branch. So that would be a different isomer. Reaction of halogenoalkanes and hydroxide ions is often carried out using sodium hydroxide and potassium hydroxide. An alternative is sodium hydroxide or potassium hydroxide. An alternative is moist silver oxide, which is prepared by adding a few drops of water to solid silver oxide. So we're saying that we want hydroxide to be replacing the halogen. I can react it with sodium hydroxide or potassium hydroxide. This is the reaction that we know, but he's giving me another alternative. I could react it with silver oxide to which a few drops of water has been added. Silver oxide is insoluble in water but produces sufficient hydroxide ions for the reaction. Write the Ionic equation for the reaction of silver oxide with water. This is silver 1 oxide, oxygen valency 2, so this is Ag2O. We're saying we're going to add water to it. This will give silver ions and hydroxide ions. Remember that we have to balance, and this would be the Ionic equation. So just one advantage of using silver oxide rather than sodium hydroxide or potassium hydroxide. Well, if I have silver oxide, it's a solid, I can filter it and reuse it again. So that is one advantage of using the solid silver oxide. This question is about fuels. The enthalpy change of combustion is the maximum amount of heat energy that can be obtained by complete combustion of a substance. Values for the enthalpy change of combustion may be obtained by direct measurement or from mean bond enthalpies. These data may be used to assess the efficiency of the fuels. Petrol is a mixture of a large number of different hydrocarbons containing between 4 and 12 carbon atoms. Octane, C8H18, is a typical component of petrol. Where is the question? The equation for combustion of octane is shown, and we're asking use mean bond enthalpies to calculate a value for the delta H of combustion of octane. How do we use mean bond enthalpies to calculate delta H? We add up all the bond enthalpies for the reactants, we add up the ones for the products, and then the delta H is the reactants minus the products. So let us look at the reactants. How many CC bonds do we have? And how many CH bonds do we have? Well, we have 7 carbon-carbon bonds, so that's 7 times 347. We have 18 carbon-hydrogen bonds, so that is 18 times 413. Plus, we have 12.5 of the oxygen-oxygen bonds. Each of them needs 498, so 12.5 times 498. This is the total amount of energy needed to break the bonds in the reactants. So this is a positive value. This is energy that we need to add to break the bonds. Now, in the products, we have what? We have 8 carbon dioxides, but each carbon dioxide has 2 CO bonds. So that is 8 times 2 times the 805 plus. How many OH bonds do we have? We have 9 water, but each water has 2. So this is the total amount of energy released when the bonds in the products are formed. Now, reactants minus products, that gives me the overall delta H for this reaction, which in this case comes out as a negative value, of course, because this is combustion. The standard enthalpy change of combustion of octane is actually this. Give 2 reasons why this value measured under standard conditions is different from the value we obtained. What was the value we obtained? This is the value we obtained. So this is lower than the actual value. We said any delta H calculated using bond enthalpies would be lower than the actual value. Why? The bond enthalpies in the table are average values, and they are values for gases, while the octane that we're talking about is a liquid. When petrol is used to power a car, the energy available is less than the theoretical maximum. When 1 kilogram of petrol powers a car, the energy used to move the car is 11 megajoules. Calculate the percentage of maximum energy that's available to move a car, assuming that this fuel is octane and we have the delta H of combustion. What are we talking about here? It has petrol, and we're saying if I have 1 kilogram of petrol, it gives 11 megajoules of energy. What do we have? We have this equation, octane plus 12.5 oxygen to give 8 CO2 plus 9 water. And we have MR of octane is this. Now what do we need? We need the number of moles of octane. If I have 1 kilogram, that is 1,000 grams of octane, because we're saying the petrol, assume it's octane. So we have 1,000 grams over the MR of octane. That gives me the number of moles of octane. And we're saying that 1 mole gives 5470. So this number of moles would give this number amount of energy released. The number of moles times the delta H. Remember that the delta H given is kilojoule per mole. So this multiplied by the number of moles will give me the total amount of energy released from the 1 kilogram of petrol. Now, we are using it to move the car. It is 11 megajoules. So the percent efficiency is the 11 over what we should have obtained times 100. And that gives an efficiency of only 23%. Give 2 reasons why the energy used to move the car is less than the theoretical maximum. Where did the rest of the energy go? Well, we have loss of heat to the surroundings, and we could have income. Two alternatives to hydrocarbon fuels are hydrogen and ammonia. Hydrogen burns to form water as the only product, but hydrogen is extremely hard to liquefy. Ammonia is easily liquefied, but it is toxic. Compare and contrast the intermolecular forces involved when hydrogen and ammonia liquefy. Remember, liquefy means what? Means the gas particles are coming nearer to each other. So when it is easily liquefied, then they come nearer to each other more easily. So we're saying that the ammonia is more easy to liquefy and we need to describe how the forces are formed. So what kind of forces do we have in hydrogen? You should realize that hydrogen has weak London dispersion forces, while ammonia has hydrogen attached to an electronegative element, so the particles or the molecules would have hydrogen bonds between them. So both hydrogen and ammonia molecules have weak London dispersion forces. These are formed due to attraction, because he's saying describe how these forces are formed. They're formed due to attraction between the induced dipoles of the molecules. So the electron cloud of one induces a dipole in the electron cloud of the other, and the oppositely charged dipoles are attracted to each other. Hydrogen molecules have a smaller electron cloud, so they have weaker London dispersion forces than ammonia. So that is one difference. Ammonia, in addition to the stronger London dispersion forces compared to hydrogen, it also has hydrogen bonds between the molecules, because there is electronegative nitrogen atom of one molecule attracted to the hydrogen atom of the other molecule, and hydrogen bonds are stronger, so the molecules will come together faster or easier. Methanol is used in the production of many materials and chemical compounds. It is manufactured from methanol by reaction with oxygen at a high temperature using iron molybdenum oxide catalyst. Maxwell-Boltzmann distribution for the reaction is shown. On the diagram, sketch the Maxwell-Boltzmann distribution for this reaction mixture at a higher temperature. Now, when we have a higher temperature, what happens to the Maxwell-Boltzmann distribution curve? The peak is lower and the graph shifts to the right, because all the particles now have more kinetic energy than the original particles. So all of this shifts to the right. Then the next question says, using the Maxwell-Boltzmann distributions, explain why increasing the temperature and adding a catalyst both increase the rate of reaction. So when we have higher temperature, why is it that the reaction rate increases? And when we have a catalyst, why does it increase the rate? You should know that at higher temperature, particles gain more kinetic energy. More particles have energy higher than the activation energy, so there are more successful collisions. A catalyst provides an alternative pathway with lower activation energy. So instead of having the activation energy to the right, when there is no catalyst, the activation energy moves to the left. So now there are more particles with energy higher than the activation energy, so more successful collisions. An alternative method for producing methanol uses a silver catalyst at a temperature of 650. Remember, the previous one was a reaction of methanol with oxygen to give methanol plus water. This new method is producing methanol from methanol using a silver catalyst at a temperature of 650. Then the question says, suggest one advantage and one disadvantage of this method other than the cost of the silver catalyst. So don't say the silver catalyst is expensive. But what advantage could we have for that second equation? You can see that in the second equation, the products would have lower molecular mass, and that means that that second equation would have higher atom economy. Do we remember how to calculate atom economy? Atom economy is the molecular mass of the required product, so in this case the molecular mass of methanol, over the total molecular mass of all products. So of course in the second equation, the MR total of all the products would be less than that first equation up there, so it would have higher atom economy. But what is the disadvantage? Remember, the second equation is working at 650 degrees Celsius. The higher temperature would require more energy, so this method would be more expensive. Explain how the infrared spectra of methanol and methanol can be used to distinguish between the two compounds, stating the relevant bond stretching vibrations and their wave number ranges. So we want infrared of methanol. You should realize that methanol is an alcohol, so it has a peak for the OH at about 3000 and something, but no peak for the C double bond O, which appears at about 1700. So this is alcohol, so no peak, sharp peak for the C double bond O. That means this is an alcohol. But if you look at the IR of methanol, remember that methanol has a C double bond O, so it would have a sharp peak at around 17 something. It would also have peaks for the CH bonds of the aldehyde at a little below 3000, so those peaks at 28 something and 27 something, these are due to the CH of the aldehyde. So the methanol has an OH peak, and you get the exact numbers from the data booklet. The OH for an alcohol should be at around 3750 to 3200. And we have one for the methanol, but of course none for the methanol. For the methanol, we don't have a peak for C double bond O. For the methanol, we do at 1740 to 1720. So this is the one for aldehydes. And the CH peaks for aldehydes at below 3000, which is 2900 to 2820 to 775 to 2700 centimeter to the minus 1. Section C is talking about toilet cleaners. Products used to clean toilets work in two ways: removing the limescale that collects in the toilet bowl and disinfecting the bowl. Limescale contains calcium carbonate, which is removed by reaction with acids. The strongest acid used in toilet cleaners is hydrochloric acid, although weaker acids such as methanoic are also used. Disinfectants are essentially chlorine dissolved in aqueous sodium hydroxide. The effective disinfectant in these solutions is the chlorate ion ClO-. Now, when using all of these things, state one safety precaution that you should take when using a toilet cleaner containing hydrochloric acid. Of course, the main safety precaution would be to use gloves. You could also mention safety glasses in case anything, or to prevent anything from splashing into the eyes. The equation for the reaction of calcium carbonate with hydrochloric acid is shown. Write the ionic equation. How do we write ionic equations? We said solids, liquids, gases are copied as they are. Aqueous is ionized. Ionized means you break the HCl. The first one is positive, the second one is negative. Remember, we have two H's and two Cl minus. to give calcium chloride, which contains one calcium ion that has two positives and two chloride ions. Remember, the number of positive or negative is the same as the valence. And then we look at the equation and we cancel whatever is the same on both sides of the arrow. So in this case, we have chlorides on both sides of the arrow, and what we're left with is the ionic equation, calcium carbonate plus 2H plus, to give calcium 2 plus water plus CO2. A 750 centimeter cube bottle of a toilet cleaner contains 85 grams of hydrochloric acid. Calculate the maximum mass of calcium carbonate limescale that could be removed by 50 centimeter cubed of this toilet cleaner. So, the toilet cleaner contains 85 grams of hydrochloric acid. We have 750 containing 85 grams. He's talking about 50 centimeter cubed of this toilet cleaner, so the 50 centimeter cubed would contain 5.7 grams of HCl. Are we okay? Straightforward cross multiplication. The 750 has 85, so the 50 will have how much? So it will have 5.7 grams of HCl. Now I can get number of moles, mass over molecular mass. So that's the number of moles of HCl. Then we're asking about calcium carbonate. Where is the calcium carbonate? From the equation, 1 mole of calcium carbonate reacts with 2 moles of HCl, and that means the number of moles of calcium carbonate is half whatever is the HCl. So now we have the number of moles of calcium carbonate. Now what is he asking? He's asking for the mass. The mass is number of moles times mR, and that comes out to be 7.8 grams. Chlorine gas reacts with water. State the classification of this reaction. Justify your answer in terms of the relevant oxidation numbers. Now, if we look at this equation, we will find that chlorine has oxidation number 0. It's an element. HClO, the O is minus 2, the H is plus 1, and that means the chlorine has to be plus 1. In HCl, of course, the H is plus 1, so the Cl is minus 1. And that means that this kind of equation is what? This kind of reaction is disproportionation reaction, in which a species is both oxidized and reduced in the same reaction. So the chlorine is oxidized when the oxidation number changes from 0 to plus 1. Increase in oxidation number, that's oxidation. And it is also reduced when it goes from 0 to minus 1. This is a decrease in oxidation number, and that is reduction. And we said the reaction that has both is called disproportionation reaction. Then the question says, when 5 centimeter cubed of a disinfectant reacts with excess hydrogen peroxide, 113 centimeter cubed of oxygen is produced, measured at room temperature and pressure. Calculate the concentration in gram per decimeter cubed of sodium chlorate in the disinfectant. Give your answer to 2 significant figures. So what is the information given? He says it obtained 113 centimeter cubed of oxygen, and we want to know how much NaClO we have. Okay, so the 113 centimeter cubed of oxygen, the first thing we need to do is get number of moles. So number of moles is volume over 24, of course, because he said measured at room temperature and pressure. So this is the number of moles of oxygen. Remember that the volume of oxygen is in centimeter cubed, so we have to divide by 1,000. Okay, then from the equation, where is oxygen and where is NaClO? Well, The equation says that 1 mole of oxygen is produced from 1 mole of NaClO, so the number of moles of sodium chlorate is the same as that of oxygen. Then what do we want? We want concentration. Okay, concentration in gram per decimeter cube. So I want the mass. The mass is number of moles times mR of the NaClO. This gives a mass of 0.35 grams. Now we want concentration, so that is the mass over the volume, and that gives me 70 grams per decimeter cube. Remember that the volume of the disinfectant was 5 centimeter cubed, but we have to divide it by 1,000 to change it to decimeter cube before we put it into the equation. Commercial disinfectants are often made more viscous by adding propane 1,2,3 triol to the aqueous solution. Suggest how propane 1,2,3 triol makes disinfectants more viscous. Viscous means the particles are attached to each other more strongly. So what is propane 1,2,3 triol? This is propane triol, and that means we have 3 OHs, and that means each molecule can form 3 hydrogen bonds with other molecules. So the molecules are strongly attracted to each other, and that makes the liquid viscous. Toilet cleaners that remove limescale should not be mixed with chlorine-based disinfectants. Explain using the relevant equation why these two types of toilet cleaners should not be mixed. Well, let us see. The information that was given at the beginning says disinfectants are essentially chlorine dissolved in sodium hydroxide, and the strongest acid in toilet cleaners is hydrochloric acid. And that means this equation where we have chlorine plus water to give HClO plus HCl, if I add this is the reaction for the disinfectant. If I add the acid to it, that means you're increasing the amount of HCl. What happens to the equilibrium? This is an equilibrium reaction. So we said the toilet cleaners contain HCl. When we add it to this reaction, then the equilibrium shifts to the left. Chlorine gas is formed, and this is toxic. Borax is another cleaning agent used to remove limescale. Borax is a compound of sodium, boron, and oxygen. Borax crystals contain water of crystallization. The percentage composition by mass of some crystals is this. Determine the empirical formula of the borax crystals and hence their formula. So basically we're trying to get empirical formula. So let us say we have hydrogen, boron, oxygen, sodium. These are the percentages given. How do we determine empirical formula? We said the first step is divide by the molecular mass of each element. Now we get numbers. We look at these numbers and divide by the smallest. And this gives this ratio, 10 to 2 to 8.5 to 1. And we said if one of them is 0.5, you multiply all through by 2 so that they are all whole numbers. Do not round up the 8.5 and make it 9. We multiply all through by 2, so actually the ratio is 20 to 4 to 17 to 2. This is the empirical formula, H20B4O17Na2. That's the empirical formula. But that means that the formula is what? Remember, when we write formula, the metal comes first, so sodium, and then boron, and then oxygen. And then he said it has water of crystallization. Well, if I have H20O17, H20 means I have 10 molecules of water, so it is 10 water, and I'm left with 7 oxygen, so this is the formula of the compound. And that's the end of this paper. I hope this was useful. Thank you for listening.